Today's topic first I will cover the memory layout of C program. So memory layout of C program. So whenever we will generate our a.exe file. So this is my a.exe file. So whenever we generate our a.exe file, it will store into our hard disk. So when we compile our code, it will generate the a.exe file. So it is store executable file is stored in the our hard disk. So this is my hard disk. So whenever we will do dot slash a.exe, it will load into the RAM. So RAM have total 4 parts in the memory: stack section, heap section, data section, and code section. Data section have 2 parts: uninitialized data and initialized data. Uninitialized data section is also called as a BSS data section. BSS, that means block started by symbol. So whenever we are loading our doing the dot slash a.exe, it is loaded in the RAM. In the RAM, total memory are divided in the 4 parts: stack, heap, data, and code section. Data have 2 parts: uninitialized data and initialized data. And then after it will go to processor, and processor will run our code. So this is the process. So first write down, draw this diagram in your book, then we will understand one by one section. Whenever you write program, at that time you should know which type of data type you are using. So my data will store in which section of memory. Then you will understand your code better. Then first is the stack section. So stack section is our data is stored in the last in first out format, LIFO format. That is last in first out. Consist local variables. So local variables, those who are we are writing inside our function. So our main function, whatever variable we are writing, that variable called local variables. That local variables come and store into the stack section. In my program, so this is my program. So these all are the local variables, and local variables are data are stored in the stack section of memory. So inside function, whatever variable you will declare or whatever variable you will use, that will be local variable and it will be stored in the stack section. Then once we will see the storage classes, at that time you will understand what is auto. So auto variable are stored in the stack section. Then function return address. Then formal arguments. We will see all the things. So we'll see the what is exactly the auto variable, what is the function return address. Once we will in the function formal arguments, we will see all the things. So stack section consists these all the things: local variable, auto variable, function return, and formal arguments. So you should know your data is stored in the which section. It may be corrupt or not. Your stack section will be when will it will be the overflow. When we will see the recursive function, at that time you will understood the how the function return address is stored and how the it can be full also overflow. Next is the heap section. So heap section is stored dynamic memory allocation. So dynamic memory allocation, that is the runtime memory allocation. So I need 4 byte data, so I will use integer. So I need more than 4 byte. We will see the how to take array and all things. So that is we know previously how many bytes our data we need. In dynamic memory allocation, at the time of creation code, you don't know how many bytes of data you need. At the runtime, it will allocate the memory. Suppose you write only 1 byte data, so it will allocate 1 byte. You will store 2 byte data, it will allocate 2 byte. Like this way, runtime memory allocation is happen using the dynamic memory allocation. That functions are malloc, calloc, realloc, free memory. This all the things we will see in the dynamic memory allocation chapter. Because of that reason, if section size is not fixed. So stack section and heap section both are growing in the opposite direction. So heap section size is not fixed. Heap section size is taking once we will do the dynamic memory allocation and runtime memory allocate, at that time it will allocate the 1 byte data, 2 byte data like this way to our variables. So if section size is not fixed, stack section size is fixed in memory. Third section is the data section. So data section are divided in two parts. One is the uninitialized data and initialized data. Uninitialized, what is the meaning of uninitialized? Uninitialized, that means suppose I will take integer I. So this is my uninitialized data. And suppose I will take integer I is equal to 0, integer I is equal to 10 or anything. Data is assigned to variable. This is called initialized data. So data structure section have two parts, uninitialized data and initialized data. Uninitialized data is called BSS, that is the block started by a symbol. So in data section, wherever the data is, the uninitialized data is by default assigned to 0. So whenever you will read uninitialized data of that, so it will not give you garbage value, it will give you the 0 value in data section data. So data section consists of static, extern. So static and extern both are the storage classes we will see, and global variable. So these all are things will be in the data section. So we will see the how to use static keyword, what is exactly the static keyword and what is exactly the extern keyword, how to use these things. Global variable. Global variable, that means before main function. After including part and before main function, whatever variable here I will take, this is called global variable. These global variable are stored in its data section. Local variable are stored in its stack section. So we will see global variable, how to use global variable, what is the scope of global variable, all the things. So global variable are stored in its data section. Static variables, external variable are stored in its data section. Data section have two parts, initialized data and initialized data. Whatever the uninitialized data are stored in the BSS section and uninitialized data are stored in the normal data section. Then code section. Code section are the read only files. Suppose in our code we have written the readme.txt, that will come into the code section. So read only files. Code section also called as text section also. So it consists of operational codes. We can call it as a opcodes. Operational codes or opcodes short form. So this size is depends on the how much big our program. In data section also size is depends on how much big program.